morning, everyone. Today is very less 10 minutes. Okay, today this lecture is only about the design. It will help you for your projects, how you identify the problem and how you can solve it. It's generally theoretical, and later on I will show you the solution for your exam problems, which we have shown you. Your exam 2 solution, I will show you how to solve the problem in your exam 2 what you have done. So let's introduce about something about design. Anyone knows what's actually design? Generally, it's an design is an application of creativity to planning, then providing an optimal solution of a given problem, then communicate the plan to others. So it's a combination of given problem, creativity, planning, optimal solution, and a communication. So how you can present it at the last. So this all combined together is actually a definition of design. So first is the given problem. So how you can identify the problem? Maybe the problem related to what the need of the day. You have to find the problem which is the need of the day, or you have to find a problem which is already existing, but you have to modify it for the ease. Then about the creativity. So the information what you get from the need or from the society, the designer should have a knowledge which is related to that information and coming up with a solution which should be new or it should be modified. So it's about designer should always have a knowledge of the information which is already provided, the information already provided, and such information a collective planning should be done and come up with a new idea. So that's a creativity of a designer. So whatever problems you are going to identify in your project, it should be either it should be already existing problem or it should have something which is existing but you want to modify it for the ease or for the performance enhancement. So it's both the things. So the designer should always be a creative. Then planning. So you have to plan a guide map for optimal solution based on such something as a new. So already it is existing something. You have to identify the results of the proper solution which is already existing if the model is existed, and if the model is new, you have to find the optimal solution using analysis, using all the structural analysis, using the last previous question. The ANSYS class already taught you that how you can uh, provide a structural analysis on the model analysis using the softwares. So this is a type of planning you have to do. Then, on the basis of planning, you have to find out the optimal solution for such problem in a stipulated period of time. It's not that the solution take a long last time. So, make your decisions using engineering tools such as mathematics, statistics, computer graphics, coupled with the information which already provided. And the optimal solution should be functional, safe, reliable, competitive, usable, manufacturable, and marketable. So you have to provide the solution which should be functional. It's not that we can assume it and just provide a solution. It's not an assumption. It should be functional. It should be safe. It should be safe enough to run the show. It should be reliable. It should be competitive. Like any other already existing solution in the market is already available there. Why we need a new solution? So it should be competitive. That what's the best we are having. It should be manufacturable and marketable. So it can be manufacturable. Otherwise, many solutions are only on the ideas. It's not existing or it cannot be manufactured. Like we can tell that okay, I want to fly. I can have a wing and just fly. So maybe it is not possible right now. We don't have so much of good actuators. So maybe it is not manufacturable right now. But in the future scenarios, maybe it can be done. So the idea should be functional. That's why we are told that it should be, the solution should be functional. Then the communication part. So tell the other people in the society what you have done. So it should be communicated through your presentations, through your the publications. That's why whatever in the DMC class, the project you submit, if the project is of good solution, then always the Professor Lin ask you guys to present it, and all the expenses will be by Lin, Professor Lin. So whatever project you are thinking of, make it in a unique way so that in the upcoming conferences we can allow you to present it. So it's always been in the previous classes. Someone has done a good job, we ask them to present in the conferences. So you have to communicate your solution to others so that you can know that already the solution is existing or not. The engineer success depends on the communication in the writing, presenting, and speaking. So how you present your solution is also important. So that's the communication part. So whatever you are doing it on your analysis or structural analysis or anything, but you have to present it properly. So that's will help you on your project presentation. The first phase you have to present it properly. So the first is the proposal present. Whatever proposal you are drafting, have the references, have the citations, and draft it. Learn some of the research papers already existing. So the next part is that was about the design. So design is generally a given problem, create a proper using creativity, find the planning, and provide an optimal solution of that problem, and then present it properly. So this all together is actually a design. So that was only a theoretical part of design. It's not related to mechanical design. If you are implementing in a mechanical side, okay, the problem should be mechanical. You have a creativity to provide a planning through a mechanical way. Like you should know the specification of the design, particular problem. Then provide an optimal solution with justification using some structural analysis. Then present it on a proper way, like in a CAD drawings or something. So it should be, if we are implementing this concept of design on mechanical side, it will be similar way. So there are the phases of design. So first is the recognition, and there is a need of problem, then define the technical specification, that is a part two. Then synthesis, that is your part of observation that already it is existing or not in the market. You have to identify, you have to search some other specifications. Then go for the analysis of your own design. Then you have to test it before saying that okay it is working or not. Then you have to present it. So it's six phases of design. So now it comes to the engineering design. Already I showed you it's a similar way. So design is the application of creativity to planning the optimal solution of a given engineering problem and communication of the plans to others. So when the design is related to engineering problem, we call it as engineering design. And when the mechanical engineering design is given as a mechanical engineering problem, it's the same as mechanical engineering design, but we are focusing on mechanical elements. When we talk about mechanical engineering design, it's about the creativity of planning and optimal solution which is focused on mechanical elements. Mechanical elements means this like links, joints, bearings. So these all are the elements of mechanical. So while you design to respond such a need, what are the considered while designing? Functionality, safety and reliability, strength and stress, deflection, distortion, stiffness. This all wordings already you have studied in your previous classes. wear, corrosion, friction, thermal, surface, noise and lubricant, weight, shape, size and life, cost, competition, marketability. So these are some of the parameters which should be considered while designing any of the need or a problem. So what are the steps to be taken while designing anything? Understand the problem clearly. Identify what you are known. Identify what you are unknown and formulate solution strategy. State all assumptions and decisions. Analyze the problem and solution strategy. Evaluate your solution. Present your solution. So initially, the steps. Step one is first you can understand the problem, and also you have to review the problem. Like already the solution is existing or not. So how you can review it? You can find out some journal papers already existing in the same scenario or already related to the same problem. You have to find out if they have. You have to read a lot of papers. Go for some review papers. You know what are the types of papers? Anyone? The research papers are presented. What are the types? So there are the research article. One is a research article where the new solution or a proposed methodology is shown. One is the review article. The review article means they show you a different in a certain area. They show you a different reviews for different already existing solutions now. Or someone has presented something on particular. Suppose in generative AI. So the review article of generative AI means generative AI related to suppose ChatGPT or using Llama or using any other tools. So one paper related to ChatGPT, one paper related to Llama, one paper related to another things. So a review paper is a combination of all this together for a certain period of time. Like for a review paper is of 5 years, maybe 2020 to 25. There will be a review paper. So if you want to know something related to some particular problems or solutions, you can go through the review papers. If you study a review paper, you can understand the concept of a theory or in one subject area, on a particular domain. So these are review papers or research articles. Mainly the research papers are of two types or the conference proceedings. Conference proceedings are whatever is presented in the conference. Like it's only a small showcase of some project. So this is another way of producing the papers. So these are the presentation part. How you can present it, either in a journal paper or in a review paper, or you can have a conference proceedings or a short article. So as seen in the phase design, the design process are interactive and iterative. Therefore, it may be necessary to repeat some of all above steps once, then once if less than satisfactory results are obtained. So above steps these steps can be repeated. Like if you go then analyze the problem with a solution strategy, but it doesn't work, what you will do? You have to again go to the step 4 or step 1, understand the problem clearly, and start to do it again. So many times happens that we understand the problem, we find out some solution, but it doesn't work. So we have to iterate it. We have to change some parameters and do it again. So many times these action steps has to be repeated. Then the economics and environment, use the standard sizes as possible, use large tolerances as possible, think of mass products, break even point, think hard of environmental effects. So you have to check that it should be sustainable, it should be economic, is the cost effectiveness, and the environmental continuity should be there. Otherwise, it's not like that you have put higher safety factor like 32 or 35. In the next class, I will show you the AMR which we have built, and the safety factor is 32. So we build a super strong structure, but we don't need it. So we have used a lot of metal in it. So if you are building something and the cost and the environment you are not taking considered. It's also a not good solution. So you have to check each and every concept of this. Then is the safety and product liability. So manufacturer or designer always take the responsibility no matter how long the life of the product. So be careful for excessive promises. Be sure for product adequate warning and instructions. So designer should always review, test and control the quality of the product. It's just a theoretical about how the designer has to work. So you have to check the safety of the product. So that's why we always talk about the factor of safety. So always our structure should be enough to sustain the variable loads. Then there are some fundamental principle of design, like as Occam razors is called as keeping things simple to start and add the details to design develops. So these concepts are actually used for designing. So the first one is Occam's razor. They give this concept gives you like first make it things simple, simple to start. Then don't make it so much complex that it should have a lot of variables in it. So if your solution should be strong enough, make it simple to solve it. Don't make it complex. Then the law, you should follow the fundamental laws of nature. Then there is a Saint-Vincent principle when the object is to be controlled, sketch it, being held at a point at several characteristics. Then the concept of golden rectangle. If you don't know any of the size, start with the ratio 1 is to 6 is to 1. So it's a golden rectangle theory of a design. They're called as the Abbe's principle. Small angular deflections are amplified by distance to create larger linear displacements. Then comes to the Maxwell reciprocity. So it's uncomfortable with a design. Try to interpreting it, turning it on its side. Self principles. Use object geometry and other property prevent a problem. See, these are all design concepts which is given like different theorems or different work areas. So I will combine it in one because it takes like a 4 hour class if you explain each and every concept. So stability, stable, neutral, stable, unstable effects to help them. Symmetry, try to design it in a symmetric way, then impose reciprocity to consider a design that is not symmetric. Parallel axis theorem, add mass away from neutral axis to increase strength and stiffness. Accuracy, repeatability and resolution. Make your machine repeatable first, then tune for accuracy. See, this is also a good concept that whenever you design something, make your machine to be repeatable. That's why we are called as whenever we have some experiments, what we do, 1000 iteration, 2000 iteration or repeatability. So we can check that it should be more repeatable enough. Finally, tell the same story each time, then correct the story with which details so the people can understand it. So your machine may be repeatable first, then go for tuning it. So first, whatever the condition is that, first make it repeatable so that it will perform every time in the same way. Then tune it to provide the same solution every time. Sensitivity, direction and reference features. Why pay for the performance in a direction that is not needed? Establish reference datums for which you measure the critical parameters. So there should be a sensitive direction and reference. Already I told you the design initial problem if you want to solve, you have to find the reference that already the problem is existing or not. So you have to find the references first. It's not like that we propose something but it's not happening. So we have to find the reference through which we can improve something. So that's why we name it the research. It's like a repetitive searching. So you have to research it. Then triangulate for stiffness. Triangulate parts and structures to make them stiffer. Load paths. Plan and load paths in the parts, structure and assemblies. draw a line or a path that force follow and seek to minimize its length. If the path and shape change significantly as machine moves, then the machine will have a limited accuracy and may have limited repeatability. So you have to check the load and load analysis on the machine. Avoid bending stresses, perform tension and compression, manage friction, avoid sliding friction, use rolling well element bearings. So you see, these are the concepts for the engineering design. Meaning, you have to manage the friction, avoiding sliding friction, use rolling element bearings. So whatever design concept is, you should avoid the sliding friction. You should use the rolling element bearings. Free body diagram and superposition to analyze a complex object, separate it into parts, label it, label the forces and movements on each part that imposed on others. Already, I told you that whenever you want solving any of the problem, structural problem, make it into simple first. Make it into free body diagram. So if you make it into free body diagram, you will be analyzing that. It will be clear showcase of all the loads acting on the beam. Then the center of action. If the forces are applied through the center of mass, stiffness and friction, there will be no movements, hence minimum error. Exact constant design. The number of points at which the body is held or supported should be equal to the number of degrees of freedom that are to be constant. So you have to properly design your constants, that which are the constant applicable to which of the solution. Elastically average design, hold or support the body when 10 times compliant points, then there are degrees of freedom to be restrained such that errors in the compliant supports points will be averaged out. So it should be elastically average design. Then stick to the figures. Initially sketch an idea first. Then provide a major coordinate system to are located in the design. The coordinates are used for modeling individual modules. For example, creating an error or predicting a machine's repeatability or accuracy. So these are some of the fundamental principles which should be taken care of whenever you are doing some project or some design. Let's go to some of the real world example by fixing a cyclic error in a linear drive. So there was a problem in this linear drive, which the figure shows here in the left side. So it's an over constant motor mount. So the linear problem shows the repeatability cyclic error. So whenever this model was designed, it's showing the repeatable cyclic error. There was error whenever the motor is running, the cyclic error. This should have a in a linear drive. So they tried tighter machining, careful alignment, premium lead screw, error persistence. Means they tried making it tighter machining. They fixed it very well. They carefully aligned it properly, but still they use premium lead screw, but still the error is going on. So the root cause, they found it that the motor was bolted solid to a screw. So unintended concept found the kinematics. So they put the solid bolted. You have seen the bolt. This is the bolts. Already they coupled it with the solid bolts. So it is actually the over constant. They make it more rigid and more fixed. So that's why this they are finding that there was always an error in the working. So as per the kinematic inside, the motor screw pairs needs only one constant at the motor. Stop the housing from rotating. Do not lock everything. So it only needs only one pair of screws. It only needs a one pair of screws, which should only have one constant that should stop the housing from rotating. Means whatever the house is there, the outer part of the motor, which fix the this motor. So it only houses it. It should not rotate together with the housing. So the kinematic part was it should only have one screw is needed. But the designer has made it initially, they put it four screws. So here the redesigning comes. The problem error was not actually the technical side. It's not about the kinematics or the machine or the rotating system. It's about the over constant. We have put two more additional screws on us in this. So this problem becomes over constant. That's why the linear drive always creates some error. So they redesign it, add a compound flexure between the motor and the screw to absorb tiny misalignments while preserving the correct degree of freedom. So in the second design, you see that they put something only a bar which is holding this drive and redesign it. Then the outcome comes that the cyclic error disappears, no need of costly lead screw, ultra tight tolerances or fuzzy assemblies. So it's a modal lead screw and carry scanning mechanism. So why I'm showing you this example, that many times we make the structure complex. We put everything together. So the concept is we have to make it simple and try it in a different way. So over constant problems also create sometimes errors. So you have to simplify your problem and showcase it. Don't think of adding this, I will add this, I will add that in the project. So it will make you more messy. Try to solve it in a simple way. Try to redesign it, and many times the kinematics doesn't cause the effect or error. The error is only costing due to your structural design. So in this case, the error was due to the over constant application because of adding additional bolted screw. Then the second example is like a material cost example. So design for manufacturing, already I told you before that as a key factor is design simplicity, material and stock, process capability rules, tolerances, assemblies, cost drivers, volume and economics, supply chain, quality risk, sustainability and verification. So whenever you are making engineering design, these are the key factors you have to consider. And always, what is the cost? Always a part which is the major function for a designer. What you need is a safety factor. First, initial is the safety factor which every designer should take care of. That your design should be safe enough to sustain. And what is the second part? Second function. The designer should take care of. Anyone? Which should be the second function the designer should take care of? Cost. The cost. Safety is the first part. Any design should be more safe. The second part is the costing. If your design is too much expensive, no one will buy it. It will not be marketable. So you have to consider the key parameters that your design should be cost effective. So that this is mainly the design for manufacturing, like engineering parts or assemblies, which they are produced easily, reliably, economically with available process or suppliers. So whenever you are designing something, think of manufacturing, how it will be manufactured. The first part, it should be safe enough, so the safety factor should be good. The second part is it should be cost effective. Otherwise, you will design something which should be not implemented. So designers always take thinking of the things that we should be cost effective. So I show you example how someone has redesigned a metal fan cover for truck sheet, and it should be redesigned to lower the production cost. So the figure shows that the 80% of the fan covers the material cost. So this is a fan cover which is designed. and which covers the 88% of the as a material using a material cost. So what we need to redesign it to reduce the material. So to reduce the material cost, you have to select an alternative material that is cheaper. The first one is you have to select an alternative material which should be cheaper than your existing material. Reflects the functional load requirements and tolerance. Like for this redesigning it, as you know that the material cost is 88%. So what you need initially, either you have to select another material which should be lower in cost than the existing material. Otherwise, use less material by making the part thinner, adding ribbed forms to strengthen it, or improving the material utilization to reduce waste. Or use the less material in this. How you suppose if you I give you a design of this fan cover and ask you to redesign it and reduce the material cost, what you will do it in? Either what you will do, you will make some holes and remove out of material. Like many of the times you have seen that there are some designs which issue like a netted holes, like a punching holes on that, like some plate with holes. So what they do, they remove the material from that. So it will be like a material reduction. The cost of material will also a part of the problem. So there are two ways which we can do this one. Already a solution is written downside. The first one is like either you can find out the alternative material or you can use the lesser material. So how the designer thinks, the product developer recognized that the material choice was primary cost driver and reduced the part size without altering the size of the opening or component matching points. The following screenshot displays the final solution. See, the designer has done, they cut from this part here. They made the opening in the same way so that the fan cover opening is the same. The diameter of the fan cover opening is the same, but they cut the bottom side, which is not necessary. So noted that the labor and overhead cost increase from because while cutting this part, your labor cost will increase from 49 US dollars to 0.53 US dollars. The material cost dropped from 7.51 to 5.63, which is 25% saving. So that why I'm showing you example, the cost is also a part of the engineering design. So whenever you are thinking of design, your material you have to optimize the proper way that your material should also be cost effective. So this is a greater example how reliable cost estimate is useful for prioritizing redesign work. A good cost vector, whether the cost is going up or down a little bit a lot, is sufficient. Like in this case, the material cost is reduced by 25%. Only just redesigning it, and the solution is the same. They need a fan because this is a fan cover. So the diameter of the fan, rotating fan should be same. So they made the diameter as the same, but they only reduce the part from here, the material from this side. So in this way, you have to think on redesigning the things where you can reduce the cost of material. Everyone got this? Another example is the material cost for two, that is a plastic seat. The manufacturer produces approximately 2 lakh seats annually. The digital marketing cost model relief, the material is 67% of the cost. So the material cost is 67% of the cost. Now you have to re-engineering this design. So the engineer redesigned the seats has two options. One is use lower cost material, the same which is the earlier example. Note that he had a conversion cost between the most expensive. You may have wanted a material that cools faster, thereby decreasing the cycle time and production cost. reduce the amount of material without compromising seat integrity. Either you reduce the amount of material used in making the seats, or you can use the low cost material. There are two options with you. So in this case, a designer have a two option making injection molded seats thickness optimization. So he make a thickness optimization, tapered the thickness from the top edge down 2 by 3 of the height from the bottom edge up and 1 by 3 towards the center. So he make redesigning it and tapered the thickness from bottom to upsides. Like from upside, it make thickness in a lower way, and the broad bottom it towards the center, the thickness will be more. So he redesigned it by making a different thickness of the in the chair, the sitting arrangement, so that thinner section cools faster, shorter cycle time. So the whenever you make for injection molding, the thinner section will be cooled fast. So you have a shorter period of productivity time. Then it will reduce the material cost, labor and overhead. If your production time is less, your material and labor and overhead costs will be always lower. So the result is $0.95 of saving as on part of 5 part, that is 19 to 20% of the cost reduction. Similarly, the second one is the black hole and enlargement. The holes which you are seeing, they produce less material. So what they do is they make the big holes. But increase in the back opening tight from 5 to 6 inch. Outcome was only few cents cost reduction. Potential comfort quality issues limited value. But while they make the holes big, the chair has a limited comfort quality. So they find that by removing they reduce some cost, but actual output, the result was a comfort. When you are sitting in the chair, you should get some comfort. The comfort was not there. So your product will be not marketable. So in this case, both the cases, I want to show you that how, but cost is not every time that you can remove the material and have the same thing. Sometimes you have to optimize it, optimize your design. That where to remove the material and where, like they make it like in the upper part, they make the thickness like this is a chair. This part they have lower thickness, and here they make it more thick. So it's like an optimized way. Say they optimize and get results, then 90 to 20% of the cost has been reduced because they make the chairs in a faster time. So if they produce in a one day, one injection molding machine produces 10 chairs. Now in this case, they produce 12 chairs in the same period of time. So it's not about only about the material cost; it's about the lower labor and overhead charges. So this was the second example how the material cost and how the designer has to think of redesigning by considering the optimization, by considering the material reduction as a case. So that was for today. So mainly it's only this lecture was only for like how you can select your project, how you can think of what to design, and what are the different parameters and of design. So let's come to the exam problem. Is the student came there?
No.
No. So this was a problem. There is a material with yielding strength of sigma y and a Poisson ratio of mu. The material is under the tensile test with a load of F and the effective stress area of A. Determine the safety factor N, which is greater than or equal to less than what the value. Which design model did you use? MSS, MSc or ME? If using a different model will answer you different, show why. So already on that day, I already write this equation for you. So sigma equals to F by A, tau max equals sigma by 2 equals to F by A 2A is greater than or equal to sigma y by 2n. Therefore, n is greater than or equals to sigma y by sigma. Because from here you can find out putting n here. So it's MSS model. So if you are using MSc, S1 equal to sigma and S2 equals to 0. So using this equation is the same. So that will be the same results for MSc and MSS. Okay, so this was the solution for your first problem. And the second problem, there is a shaft that is carrying a load of F as shown below. Determine the reaction forces R1 and R2. First, you have to determine the reaction forces, then determine the maximum bending moment in the shaft. Where is the location with the largest tensile stress along the x direction? The shaft is also being twisted by a torque T as shown below. The study first and second principal stresses at the position with maximum tensile stress along x. Yielding strength sigma y of the shaft must be larger than what level? If the safety factor is 1.5, use MD, maximum distortion energy model. So, first of all, you have to find the reaction forces. So, reaction forces means the first concept is upward and downward forces that should be equal. So, the R1 and R2 equals to F, already given. And taking the moment about R1, so here the R2 into this distance, that is L plus 2L is 3L. So 3L R2 is equal to F, because it's in the clockwise direction, it's in the anti-clockwise direction, so both are equal. So F into L. This is equation 1. Here you can find out the R2 as F by 3 and R1 as 2 by 3F. So 1 by 3F and 2 by 3F are both your reaction forces. This was the simple. I've seen that many of the students have not find out the reaction forces properly. So it's a simple one. It doesn't need anything. Then find out the moment about, draw the shear force, because it's a simple diagram, so you can just draw the shear force diagram. And here the concept is like, because here there is a torque is acting here, so the torque will acting as a impact, and at point R2 is 0. So many of them may think that it's directly to 0. But the torque will act at here. It's already we are making a torsion. Then find out the moment at Y and making a constant as FL. So your maximum moment will be 2 by 3 F into L. It will be, maximum moment will be acting at the point where the shear force changes its sign. It's a 0. So this was our first part of the problem. Then you have to find out the like a Mohs circle diagram. You can draw it. So this is the point at which there is a largest tensile stress along with the x. So sigma equal to 32 by m pi d cubed. So you can make it as 64 3 pi d cubed, and your tensile stress is 16 3 by pi d cubed. So this is the value of tensile stress, and here, and you can find out the radius with this formula: 1 by pi d cubed 32 FL cubed plus 16 d square. Now you can find the radius plus S1. So S1 and S2, your both of the normal stresses. After finding the principal stresses, because we are in the question, we have tried to determine the maximum bending moment, which is already we have find out. Then find out the principal stresses. So maximum bending moment will be at this same point. Now your principal stresses are here. Using the MD equation, S1 square plus S2 square minus 2 mu S1 S2 is greater than or equal to sigma y by m. Just substitute the S1 and S2 values here and simplify it. You will get this result. Just you have to, either if you simply put this one is also okay. This one also correct. But if you simplify it, this will be your result. No need to more further simplification. Just put the values, because this is like a constant type of problem. There is no particular value in this. So this was till the solution of that question. Any doubt? So the simple problem. Just you have to put the values. Anything else? Thank you. And start preparing your proposal, because I think next is the 4 classes. After that, you have your proposal presentation. So maybe you already defined your groups. So start talking in your groups. What proposal you want to make? If you want to discuss with me, you can just message me in the messenger. I'll reply to you. Okay, if you want to discuss on any particular project, or you want to have some, because you have to learn some papers, go through some papers and try to get a problem from them. Okay, thank you.